Clojure 1.9 introduced a new function called Seqable, which seemed like a good opportunity to have a closer look at what exactly a Seq is and what it does, both in Clojure and in ClojureScript. When modeling data in Clojure, you mostly use Clojure's persistent functional data structures, vectors, maps, sets, and occasionally also lists. This may seem obvious now, but it's a big departure from Lisp tradition. Many Lisps only have one of these, the singly linked list. Having a single type may seem limiting, but it does have an important advantage. All data can be processed in the same way. In other words, you get a uniform interface, making it easy to write general-purpose functions that work with a wide range of data. To process a list, you only need two functions, one to get the first element of the list and one to get the rest of the list. We know these as first and rest. With these two, you can deconstruct the list incrementally, one piece at a time, which naturally leads to recursive functions. To construct the list in the same way, we need a way to add one piece back onto it, which is done with cons. If everything is a list, then first, rest, and cons are all you'll ever need to handle data. Not everything in Clojure is a list, though. To have its cake and eat it too, Clojure introduced Seqs. There are many types of Seqs. Plain lists are Seqs. They are very similar to the lists from Lisp, but they also keep track of their count, so you can get the length of the list in constant time. Functions like map or filter return lazy Seqs. This means the values in the end result are only computed as they are needed. Other things like maps and vectors are not Seqs. This is something to keep in mind. Some functions, like range, vals, or keys, return their own specific type of Seq. The good news is that you don't have to care at all what type they return exactly, because they all support the same basic operations. They behave the same because they all implement the ISeq interface. Sensitive viewers, please be warned. In what follows, we'll be looking at some Java code. This here is the ISeq interface. An interface is a bit like a protocol in Clojure. Note how this interface defines 4 methods, but it doesn't provide an implementation for those methods. That part is left up to the concrete Seq implementations. First and next should look familiar, as well as cons. More is the equivalent of Clojure's rest. This shows that the methods you see here are not the same as the first, next, and rest functions that you would call from Clojure. They're related though. These Java methods are called under the hood by their counterparts defined in Clojure core. Seqs predate Clojure protocols, and so they use Java interfaces instead. This isn't likely to change, both for backwards compatibility and for performance reasons. It's hard to beat plain Java method dispatch. ClojureScript, on the other hand, got to start with a clean slate and did decide to implement Seqs as protocols. This is great because it means you can extend the protocol to existing JavaScript objects, making them behave like Seqs. This is something that isn't possible with Java's interfaces. The function names in these protocols start with a dash, which is a common pattern for protocols in CLJS core. The first and rest functions will again dispatch internally to dash first and dash rest based on the type of their argument. So Seqs are great because they allow us to handle many different types of collections in the same way. But vectors, sets, and maps are not Seqs. They don't implement the ISeq interface, and yet we treat them just the same. This is thanks to a handy little function called, perhaps unsurprisingly, Seq. This is the definition of Seq in Clojure core. From the metadata you can tell it always returns an ISeq. There's not much code because the real implementation is again in Java, in a special class called ClojureLangRT, short for runtime. Seq does its best to turn whatever you give it into a Seq. Functions like first, rest, map, or filter all use Seq internally to convert the argument to a Seq if it isn't one already. Anything that can be converted to a Seq this way is considered Seqable. To see how that works in practice, let's have a look at first. Here's the implementation. This one delegates its work to ClojureLangRT again, so let's look there. If the object passed in is already a Seq, then first knows that it can call the first method from the ISeq interface. If not, then first uses the Seq function to try to convert its argument to a Seq. If the collection is empty or nil, then the Seq function returns nil, which in Java is called null. That's why this check is needed. Now that the argument has been converted to a Seq, it's safe to call the first method, which will invoke the relevant code for the specific type of Seq. So what can be turned into a Seq? Quite a lot of things, it turns out. The first check here is simply to see if the argument is already a concrete Seq. If so, then no conversion is needed. If the collection is lazy, then calling Seq on it will realize it, computing the next chunk of values. All Clojure collections implement the one-method interface called Seqable, containing a single Seq method. This is how things like vectors and sets get turned into Seqs. Seq of nil is simply nil. In Java land, instead of Seqs and Seqables, there are iterators and iterables. If an object is iterable, then it is also Seqable. In other words, Java collection types can be used transparently in Clojure. The same goes for Java native arrays. Strings and string-like things, like buffers and string builders, are also Seqable, in which case you get a Seq of the individual character in the string. The final check is for Java's associative collections, which all implement the Java util map interface. This is the Seqable interface. Because it's an interface and not a protocol, you can't add support for it to existing classes, although if you were to implement new data types from scratch, you could use it to make them instantly Clojure compatible. Luckily, Java iterables are also Seqable, so most collection types from Java or other JVM languages will work out of the box with Clojure, even when provided by third-party libraries. In ClojureScript, there's ISeqable, which is a protocol containing a single -seq function. This one you can extend to work with types from third-party libraries. For example, the phaser game library contains a phaser.group type, which is a kind of collection. I can extend phaser group to implement ISeqable. By providing a custom implementation of -seq, it's now possible to use group objects with first, map, or do seq, just like ClojureScript collections. There's one aspect we've glossed over so far, which is the distinction between nil and the empty list. In Lisp, these are one and the same thing. Writing an empty list is simply a different notation for nil. This is convenient, because it means that checking if a list is empty, such as for a termination clause of a recursive function, comes down to doing a nil check. In Clojure, the empty list and nil are two separate concepts, so you would need two checks instead of one. The Seq abstraction tries to collapse these though. When calling Seq on the empty list, the result is nil. This is why Clojure doesn't have a dedicated function to check for emptiness. Instead, you use Seq. You can also treat nil as an empty list and add values onto it, or pass it to any other function that works with seqables, like first or map, and it will be treated as an empty list. The point of this episode has been to encourage you to challenge your assumptions. Even basic and innocuous-looking concepts can have hidden depths. Doing a deep dive like this can help to adjust your mental model of how Clojure works, which ultimately makes you a better coder.